In continuation with my previous lecture on ignition system, today we are going to discuss two protective devices incorporated in it. One is this ballast resistor numbered 5 and second is this condenser or the capacitor which is marked as 12. So what ballast resistor does, the ignition coil, as I had earlier told you, it is a kind of transformer where primary and secondary coils are there. A primary current of 3 to 4 amperes is set up when the circuit gets operated or initiated by closing the ignition switch and the contact breaker point. So a current of 3 to ampere, it has also heating qualities to the wire. So this is a copper wire. Primary coil is a copper wire, a thick copper wire, and it gets heated and the insulation on it may burn. So to protect this insulation from burning, a ballast resistor is incorporated. Its resistance is equal to the primary coil resistance, and it is a thermistor, means its resistance changes with the increase in temperature. If you see, if we plot resistance versus temperature, it is something like this. So up to a certain temperature the resistance increases this way, but after a particular critical temperature the resistance shoots up very high, so that current is limited, and for that time particularly the cooling of the coil can be performed. In fact, the coil is always it is filled with oil, so cooling takes place and the burning of insulation is prevented. Its resistance is, as I have told you earlier, its resistance is the same current is flowing in the primary circuit, and hence the heating effect in both the both coil and resistor, they are same. So it works as a protective device to the primary coil. The second thing is this condenser. Its capacity, its specifications are, it is 0.25 microfarad with 500 volts. How it works really? When the contact breaker point makes and break the contact, when the contact breaker point makes and break the contact, arcing across the contact breaker point takes place, which really erodes the contact breaker points and its life decreases. So how capacitor really protects arcing across the contact breaker point? So what happens when contact is breaking? The current follows the path of least resistance and charges the condenser. So arcing is avoided. So this is the first function, that is it protects the, so condenser protects CV point from arcing. This is the first function. And second very important function is it diminishes the EMF established due to induction in the primary coil, so that the current through the battery can be set up for the next cycle. How it does? Basically the condenser and the primary coil, the coil and condenser, they have anti-phase. They are anti-phase. When, if you see, this is the resistor, this is the coil, and this is the capacitor. So they are 180-degree anti-phase. So when coil tries to send the current in the circuit, a condenser opposes it. So what happens? The energy of the coil, magnetic energy stored in the coil, is not instantaneously given up by sparking across the spark plugs. Instead, it diminishes in this pattern. diminishes in this pattern. So the capacitor quickens this process so that the current for the next cycle can be set up. So there are two functions of the capacitor which is incorporated in the circuit. First thing is it protects contact breaker point from arcing, and secondly it helps in diminishing the induced EMF in the primary coil so that the battery voltage or battery current can be set up for the next cycle